Wow. Hello, everyone. Welcome to the water cooler. I am very pleased to introduce our speakers, um, who are also my Globe family. Peggy Foletta, longtime Globe educator, now Globe partner, who's always been doing fantastic work and helping us with, well, everything. Um, I feel like Peggy's like voice is always one of those ones you turn to for her awesome advice and guidance, and especially when it comes to hydrology. And then Leigh-Ann Olsen, who I'm going to say it, Leigh-Ann, who was Peggy's student and is now taking her place and filling her shoes and at her school.
13th
So that
year.
was that.
13th year. We're doing that, so a
That is
little.
amazing.
Since I retired the first time.
And then Sara Mierzwiak, who is from the Mission Earth team at the University of Toledo partnership. And Sara has been doing lots of work with students. She's always in the field helping them. And this is the brainchild that came out of like an annual meeting, right?
Yeah.
Um,
Toledo,
yeah, in Fredonia. So
Fredonia.
I am really happy. I watched the Padlet come in with the data. And so that is super awesome to see that and to see all the activity that you're doing and your meetings, etc. So with that, I'm going to turn it over to you so that you can tell us all about it.
Yeah, funny what just a conversation at the Globe meeting can lead to, right?
I'm so glad that you joined and Lynn joined because, wow, it's a collaboration that I really love. So here we are, um, Globe Macromappers. And you can see, we've been introduced. Lynn is not with us today. We have a couple videos from Julie and Dario who are involved with our project, and then Leigh-Ann's here and will help us out a little bit. Next. So the agenda here is an introduction of Macromappers, the Google Map, and My Map, and the Padlet. Number two, purpose and general description of the Globe Freshwater Macroinvertebrate Protocol, the Macromapper background, lessons learned, and some people using non-Globe protocols. Dario's clip about he's just inspiring, you'll see. And so is Julie. She has some amazing tips for teachers. And Globe protocol, actually going through the Globe protocols. Before we were doing non-Globe protocol assistance for some people, but we're starting to try to videotape more of the Globe protocols. So we're starting that here. And then Leigh-Ann and I did a case study here at Elkhorn Slough last weekend. We didn't know that it was going to be a case study until we started splashing in the water. Next page. So
You want me to open this one?
yeah.
Okay.
Let's see. Okay, so who, what, when, where, why, and how is of this Macromappers. So it's grades 4 through 12. And grades 4 through 12 is not the Globe protocol. They are middle school, high school. So we're going down to age 9. Globe teams from around the world choose a local hydrosphere study site to investigate relationships between hydrosphere, atmosphere, and biosphere. And when do they do this? Well, the macroinvertebrates is twice a year, 6 months apart, and depending on where you live in the world, and we've got people all around the world who are in the program, it could be fall, spring, dry, wet, depending on you. Whenever the highest abundance of macroinvertebrates exists, that should be one of your times, and then 6 months later, where this is a fresh water body activity or protocol accessible to students. So, it's got to be, it's a river, stream, pond, lake, reservoir, or ditch. So why should we look at macroinvertebrates? They tell a lot about the conditions within a water body, besides the fact that they are so cool to look at. And a lot of them are sensitive to some of the chemical measurements of the water, like pH, dissolved oxygen temperature, salinity, turbidity, and other changes in the habitat. Macroinvertebrates record the history of a water body because many stay within a small area and live 1 or 2 years while the water flows by. Globe teams are conducting research involving history, culture, and health of their water sites. They are conducting macroinvertebrate surveys at the water sites and are sharing findings about their individual community, culture, and water sites with the other Globe teams around the world. How? How are they doing this? Using all-inclusive Globe sampling protocols is what we had before, and I put in parentheses, and we are now offering simpler ones as well. We want the kids out there. And here, let's see, is this you, Sarah?
Yeah, so we put together a Google My Map, and if y'all want, you can click on the link and explore it, but you can see we've pinned our member locations. This is an older screenshot. We actually have more members now. And then also we have a Padlet that has the link to the map in there. And the Padlet is where folks enter their information. We have prompts, the questions in the first column. Second column is resources for the members, and then a column for each member for them to put information in about their sites. And then we also have a shared photo album where anytime our members go out and do macros activities with their students, they've uploaded lots and lots of photos and some really cool videos, and that link is there also. So, Peggy, you want that one?
We're done with that slideshow.
That one, okay. And go back. And then the links are in this slide set here. And then the video link from the presentation that we gave previously at the annual meeting is there. So what are macroinvertebrates? Just like Peggy just said, they're little tiny guys that are fun for students to look at. And you can see them without a microscope, and they live around living or dead vegetation. And they can be on the surface or in the sediments of water bodies. And like Peggy said, they can tell us a lot about the quality of the water body and are sensitive to changes in their environment.
This is the Globe Freshwater Macroinvertebrate Protocols, and the purpose of them are to sample, identify, and count macroinvertebrates at the hydrosphere study site. And the Globe protocol is middle school, secondary, and as we said, we're doing down to 9 years old, and twice a year we mentioned. And this is what the students do. There's two bolded because we really are emphasizing those two, but the others are important as well. To identify the macroinvertebrates, to share observations by submitting their data in the Globe archive, if they can, communicate results and collaborate with other Globe schools. And that's all part of this program. They use biodiversity and that's right, and other metrics for their research and explore reasons for changes in the macroinvertebrate community. So in year one, some teams had success, others were, they got a slow start. I mean, it's a tough protocol. Some people that in our community have done macroinvertebrates for a long time, and others, they're just trying to figure it out. So, and teachers are busy, and this protocol, there's a bit of a learning curve. We want to help with that. That's why we're here, and finding time to fit it in the curriculum. So we're working, still working with everybody. We made some adjustments after the first year. We suggested that yes, we would love to have them conduct Globe protocols, but also we thought that using a simplified non-Globe pollution tolerance index or a biodiversity method for collecting macroinvertebrates, which, at least we get them out there looking at them. So that the options of what they can do is just they can do one of these surveys, or they can compare, if they are doing the regular protocol, the water chemistry to the biodiversity, the land cover or weather with biodiversity, or whatever. I mean, we want investigations all around. So we're We have a link to the pollution tolerance index for younger children or for those who don't have time to do it any other way. That first blue link is basically a Zoom meeting we had with our teams a few months ago, but we're not going to look at that. We're going to look at a few of the slides from last year's Macromappers water cooler because we were here last year and we figured, and it was, I think, was it 5 through,
August. Yep.
let's see, number 5.
Okay.
Okay, so this is the simpler method of doing a pollution tolerance index. And this one, you can just use the handheld nets. A lot of people use them anyway, but it's not Globe Protocol. And anyway, step by step. This is a video. There's a video link right there that you can watch the whole video. Let's go to the next slide. And so this woman is demonstrating collecting macros in different locations and putting some materials in the water so that they can hide and not get too hot. Next. And it continues on, and you can see one of the critters is isolated there. And next. And the tools, like a simple, plastic spoon. White is the key because you can see them against these dark critters against a white background. And here is one critter on the left, and then here's a key that we were using. And basically the key starts with shell or no shell. This one doesn't have a shell. So we go down to legs or no legs. This one you can see has legs. And then we go down to the next level. And it's 10 legs.
10 plus. Yep.
It's hard to
10,
read. I'm
10
wearing
plus
my wrong
4.
glasses today. But they have 3 pairs of legs, so that's the direction we went. And then it's wings or no wings. And this critter doesn't have wings, so we went down to the right. And it has 3 tails, and it is a mayfly larva. So that's how the key works. And we can skip that one. We could go through another critter. But these critters, we can go next. And if it's diverse, it's more, it's less polluted. Okay, next. And we need to remember to return them to the body of water. Next. And this key is available for them to print out and use if they want to, but it's from Wisconsin. You should try to get one from your local area. That's always preferred. Next. And here on the left, this is the actual data sheet for Globe. And then the one in the middle is a pollution tolerance index. So here, these are basically what we're saying on this second year is, pick one or the other, do what you can. And on the right side, it shows the middle pollution tolerance index filled out for a location, a guide for the teachers there, and some links to get those sheets.
Okay.
And that's that.
All right. And then this is Dario's video. And let me just give me a moment here. I'll copy this. And then I have to get the passcode. Get the passcode. And then we'll see what Dario has to say about his work. No, don't save it. Okay. And there's my weird head.
I went with my students on April 5th with parents, a very big group of parents, grandparents, and the smaller kids in the family. They worked together. We made some measurements, macroinvertebrates, temperature. We determined different characteristic, I don't know, about the soil near our creek, and we made pH, obviously. We collect a new species of macroinvertebrate, and we have new data to compare with our last on October. And we are working on this project with my students. They are really, really involved. they really love to work with the family, and it's a great experience, a really great experience, and I'm really glad to you to let me be a part of this amazing group. I'm really proud. I'm really proud. Really.
That's amazing. That's awesome. It's a family event.
Do you want me to stop it there?
No. Mm-mm.
Oh, okay.
I've never thought of
Yes.
doing it
You
that
gotta-
way. That's a
you
great
gotta hear the
event.
rest.
Okay.
We have the same activity on November. Each year, we open the school to the community, and it's a great moment to each of family know the what are they working during the year. It's a great day, a family day. Yes, they never use this kind, but it's like we are open for for present our project to the community, and we invite some people from like my superiors, you know, and it's a great uh, party to celebrate our work during the year with the students. Yeah, yeah.
That's awesome.
Each student has different desks inside the school, outside the school, and they present their posters, how they make, for example, they characterize the soil, or how they make the air temperature, the clouds, and the parents are really involved. It's a great experience. I'm a part of a great group of teachers.
Dario,
This is
sounds
the
like I need to get my passport
main
out
reason.
and visit.
Everybody wanted to go visit.
I mean, yeah, and how cool is that he turned it into a big event like that?
Yeah,
So let
he's
me go to
inspiring.
Yeah, he is. Yeah, he's very active with his students. Okay, and this is a video from Julie Hauk, who I get to go visit and work on macros with her students, and we've learned some very practical tips, and that's what she'll talk about.
Hi, my name is Julie Hauk, and I teach kindergarten through fifth grade STEAM or STEM at a public school. And one of the challenges I had was getting transportation and getting to a site. And so something that I started doing was collecting the sample myself and bringing it into the classroom. And then I'm able to do it at least 2 times a year. And I can hold it with varying grade levels too, now that I've worked out some of these tips and activities to be able to make it happen.
So yeah, like you said, Peggy, earlier, using that white bin made all the difference.
We
Yeah.
found that some tools work better than others. It's really nice to have clear bins or white bins. Also, to find the basters or large eyedroppers, you can kind of suck the water in and the macroinvertebrates without harming them, and then put them into a petri dish or a small bowl to be able to look at closer. Ice cube trays also can work well if you have those on hand. I like to have varying magnifying glasses, so just handheld magnifying glasses, a macro lens, where you can put the magnifier right on the petri dish, or you can even do microscopes. I really like the digital, where you can see either the screen or on top, or you can hook it up to a computer screen to make it even bigger. And the students love getting to see close up and getting to really investigate the macroinvertebrates. Have the students use an identification chart to be able to look at maybe how many legs it has, what identifying features there are, if there's a shell, and then also mapping the segments and parts of the body if there's a tail, and being able to decide yes or no, and then follow the flow chart. This kind of bridges the gap between passive observation and active scientific classifications.
All right, and he has 3 tails. Okay, so which one do you think that he is? That he's got tails. Yeah, see, because he's got a 1, 2 on the side. He's got his 6 legs. Come on, buddy. Yeah, good job.
You guys say?
Yeah, he found it. They play.
Job. One thing that we realized was you don't always have to do a whole class at a time. It actually works really nicely if you create a small station at a table or a area in your classroom and call up students in groups of possibly 4 to 6. And the students can work in that group and discuss, and you can kind of be the guide on the side and help them as they're making those decisions on the chart of where to go and how to identify it, and to really give them a hands-on experience. And it's okay to have the other students working on something else. It could be at their seats, independent work, or even on the computer, and then call those groups over into small groups. We found that works really nice, especially if you don't have someone else in the room to kind of help you with doing a larger group setting. That works really well. And you only have one station then to clean up and to have a sample at. So it's really nice to do it that way.
I can't believe she put that video together so quickly. That was impressive.
Yes, pretty awesome.
Okay.
So,
Peggy? Yeah.
yeah. So now we're talking globe freshwater macroinvertebrate protocols. Taking chemical measurements in a water body is like looking at a picture of the water conditions at that very moment. But when you take biological measurements, it's like watching a movie, viewing what the critters look like after they've experienced living there over time up till today. So really, it's measuring different things. Here are the 2 types of nets for the globe protocol: the kick screen for moving water with rocky or gravel bottoms, where you kick and the water flows in from the current, and the D-frame net for muddy bottoms with no current, that you have to do the moving. And here, these globe instructions for making a D-net and a kick net from the past, we have a link here. I don't think it's still there. It hasn't been for a long time, but it might be. But anyway, we have the link. Okay, next. And here's the macroinvertebrate discovery activity back in 1997. This was the activity that for a diversity index when there was no globe protocol for macroinvertebrates. It was an activity. And so my students did that activity in the Merced River watershed over 14 years, twice a year at least, along the rivers there. And this biodiversity index was a decent way to do it. And so, but now we have protocols.
Yeah, so we could try to play that video and see if it plays a little bit.
Okay.
That's the Kings River.
Yeah.
Welcome to the Kingsburg.
No. That's all right. You can mute it. But basically what I was saying in here is that you want to make sure that you're setting up your site. So the first thing you want to do is really observe the site, have the students go out and observe it. You want to make sure that, like I said, it's easily accessible. There's a large area that you can collect from. And then knowing a little bit about the story of your water, because it can be different depending on where you're at. Like for our Kings River, it only flows through part of the year. So I have to make those decisions on, okay, well, is it flowing now? Can I go out there and collect? And, it's kind of hit and miss sometimes. So most of the time it's just running during the summer and I don't have any students. So trying to kind of know a little bit about your waterway is important. And then one of the protocols you want to complete before doing any kind of survey would be the water walk activity, where they're making observations, they're going through and analyzing and even mapping out the water that you're going to be using, and noticing what it looks like, what it smells like, what it feels like on that particular day. All that metadata is really critical for understanding maybe the chemical tests that you're doing, as well as the macroinvertebrate tests that you're doing.
Okay.
And so then you want to be able to document and map your site. So you set out an area of about 50 meters and you're marking with these globe flags. You can see them in the video, those pink flags every 3 meters. and then kind of drawing out the map of the area. And they have a sheet for that on the Globe website for you to be able to help students do, or you can do it if students are not able to, but it's really great to have them kind of noticing the different features and getting a feel for that. And taking pictures too.
And I just added this slide kind of last minute, but habitat types for sampling. This part of the protocol is a little challenging, trying to decide what all the different kind of habitats you have in the site that you've selected and which protocols to use for it. So this is bits and pieces of the protocol in the Globe website. It talks about fast flowing water, where you have pools, riffles, and runs, which are defined here. And that's what we had when we did the Merced River. Or do you have still water, and you have you could still have submerged vegetation, vegetated banks, muddy bottom, and gravel or sand. There's just a variety of different habitats. If you are doing multi-habitats, like here in the purple here on the right, this is the ID sheet where you put your data sheet. For riffles, runs, and pools protocols, you need 3 samples. It's either like 2 riffles and a run, or 1 pool, run, and 1 riffle, depending on which you have more of. But if you're doing multi-habitat protocol, where you might have some submerged vegetation, muddy bottoms, and gravel, the Globe protocol is to have 20 samples based on the percentage of each in your site. That's a lot of samples. And so we are reminded of metadata. And we are reminded, and we can even imagine in our own heads how much time something like this would take. And knowing people are busy, they can use metadata to explain, that we did 10 or we did 5, and just explain what they did so people understand the data that they've submitted. What Leigh-Ann and I did this last weekend, Saturday and Sunday, was she came to the coast away from the heat of Kingsburg that I remember so well. And we both wanted to do a macroinvertebrate survey because we hadn't done one in a while. And this pond is behind the visitor center, probably 400 yards from me right now. And let's see, it was created in 2017, so it's artificial. The water flows in from the reserve parking lot over here. There is no outlet. It sometimes completely dries up in the late summer because we don't have rain in the summer here on the west coast of. It is currently covered with duckweed, which, by the way, is a native plant. It's a little plant that floats on the water.
Okay. Yep.
And so here we are going to demonstrate how to the submerged vegetation protocol.
I think we probably need to speed up, so
well, we're pretty
go.
much.
Yeah.
I mean, doesn't take very long, but so then at that point it'll be over, and so you bounce on the bottom and then sweep up through the vegetation.
And once you bring that net with all of that sample in there, you want to be able to rinse it out, but you want to rinse it out with isotonic water, so water that these organisms are used to. So you do need to previously filter out some of that material and get just kind of filtered water that's still part of that water area. So we have 2 different filters here you can see that we're using. There's about a 5 millimeter soil filter that we used, and then the smallest thing we had a pantyhose filter, but you want to have at least 0.5 millimeter filter for that. And then once you have that water in your spray bottles, you can use it to rinse off your sample and make sure that you get all of the macroinvertebrates you need. And then here's another version of that sampling. If you have a muddy bottom, we demonstrated on land just to kind of show what it looks like underwater, but you'd be doing this underwater about 4 centimeters into the mud and going back and forth in a meter square area before pulling up and letting it drain.
And this is pretty important that people see or understand how to do that protocol.
Right.
Okay. And then here, yeah, doing the same thing underwater. And
Okay.
and so what we didn't know we would find is very little. We only found 2 species in our samples. They are called amphipods everywhere, and or scuds, and then some red oligochaete worms. And one of the visitor center staff said, "What's the dissolved oxygen?" So of course we went and got a water quality kit and we took some measurements. Look at this, dissolved oxygen, 0.6 milligrams per liter. Lowest I've ever seen. And then we got conductivity, alkalinity, and pH, which is amazing. But the little plant is giving off its oxygen to the air, and it's blocking all the light below. So we have a classic case of eutrophication. And here's what the pond looked like in October, and you can see the pipe that comes in from the parking lot. So this body of water does change. Leigh-Ann had a comment though about what her students.
About a year ago, about last February, 2025, I had taken my AP environmental students to this pond to just try out macroinvertebrate surveys. And at that time, it was covered with kind of a reddish, what was that plant?
It was a fern, a water fern.
Yeah, water fern. So it didn't have as much duckweed. And we found quite a diverse group of organisms, a lot of damselfly, nymphs, and little diving beetles and just all kinds of stuff. So it was interesting to see that just within that 1 year and a couple months time, how much it had changed, not just visually, but also within that.
So the reason to do it twice a year. Yeah. So please join us if you're interested. Year 3, Macromappers. And here's a QR code if you would like to join us. So any questions? That's it.
Oh yes, and we promised that was not a real duck.
I want to just point out real quick, one of the cool things about having the group, especially with the interactive Padlet, is that not only are we sharing the endeavor of collecting macro data, but it's also that opportunity to share local culture, right? And stories behind these water bodies. So these kind of more qualitative information that doesn't necessarily get shared very well just through the Globe database. So that's been a big advantage of having this group.
It's really nice to have Bhutan in here, the most carbon negative country in the world. And they have some issues of, glaciers melting and creating humongous problems with downhill water flow. And then South America and then, the west coast of the US and the mid and east coast of the US. It's really kind of inspiring to work with all these people. So it's certainly worth the effort. And I hope more people join and that we get some of the others that haven't been active. So.
Any other questions for our presenters? I think you were very thorough. You left us with no questions.
I have a question. I'm looking at the Padlet right now, and it's fabulous. I love it, and I've seen it before. But when people are entering, like I'm looking at, Julie has some data there. Is there and maybe I missed this. I'm sorry if I did. Is there a template for the data, or like a Google form that everyone is using, or just people putting up their data any way they can?
They're doing it right now. They're doing it any way they can.
Okay.
Yeah. Um, we need to have probably some discussions about that Padlet because it gets to be pretty darn long, and then you can't see it all. And so what's the next thing after Padlet? That the next Padlet
Well,
with tabs.
yeah, really. That's a good idea.
Yearly tabs.
Right.
That would be helpful.
Yeah, and I've worked with Julie at trying to get some of the data entered. We had some hiccups the first time, so we still plan to get the data entered into Globe. Um, but that's probably a next year endeavor.
Things are, it's been different this year for all of us and for our project as well. So we're hoping, that we keep it going and that some others become involved because we haven't really had any classrooms interact with each other. We were hoping that we would get to that, and that hasn't quite happened yet. But we're hoping this year might be the year.
And right now, you said that everyone's kind of collecting different data. It doesn't seem like
Not everybody's putting it on the Padlet either. So
Right.
they share in our Zoom sessions. And we really need to sit down. We could probably use some advice from you guys. All you are experts that could really help us out with some suggestions. We really need to, do the best we can.
Right. And it's complicated data to share, right? It's not just like sharing one data point, like a water temperature. So there's a lot of data from every observation, every time a teacher takes a group out. Or in Julie's case, she brings the water to her students, right? So the more data you have, the more complicated it is to share.
And we want them to tell their water body story. What's it like upstream? What's coming your way? How has that changed? How is your cultural activities in town related to your body of water? We want to hear those stories. And so we need a format to move that along. And I know some of you could probably help us with that. Having a challenge, I guess, or, something like
could you
that.
use story maps to do that? And then you could
That's a
put them
great
all
idea,
together.
Jen. Yeah, that's a really, really good idea. We should look into
And then
that.
the Padlet could have the story maps.
Right.
Mm.
I think we talked about
Like
that early
a
on.
link to the story map.
Right, right. It's just the Padlet was the easiest to get all these different users from around the world to enter their information into. So, but maybe we could take what's in there and convert it into a story map view would be really cool in the
Well,
future.
at least an example.
Yeah. Right.
Yeah. I mean, start with us, right?
Right, right.
And our people we interact with directly.
And the
Yeah.
IVSS or the VSS can, you are able to submit a story map
Right.
this year. So they could take what they're doing and enter it into the VSS when those start up again. So
That's a really good point.
Yeah, thank you.
Right. Yeah, I think these first 2 years we've just been kind of fumbling trying to form this. We've been making it up as we go along, and now we're seeing ways to refine it, right? And make it even better.
Yeah, that's exactly it. We kind of just dove in.
Mm-hmm. No pun intended, right, Peggy?
I wouldn't dive into my pond. I do like swimming though.
Jessica said, or a PowerPoint template for a poster. Yeah, that's a good idea too.
okay, well, I didn't even look at the clock because it was I lost track of time. But it is 2 minutes, 3 minutes now after the hour. So usually I try and end right on time. But I just want to thank Peggy and Sara and Leigh-Ann for sharing with us, along with the great like compilation of PowerPoint that you put together with the videos, and it was all multimedia with tips, tricks, and you covered like a great history of the project and where you hope to go. So I look forward to watching this grow. I think that this is a great example of how the community started something with some great leadership, and you've engaged a lot of the community in doing this. So thank you so much for leading this effort and for gathering people from around the world in the Macromappers community.